Good evening, everyone. Our students, how are you? How was your day? Right, today we want to continue with the topic on developments with regards to transition pieces. In fact, we want to finalize today. So what I have today is a task from a past exam paper, right, which looks at the hexagon to rectangle in terms of the transition piece. Then on Saturday, we are going to relook again at the transition pieces where we have got 2 hours in terms of our interaction. So I want you to take note of whatever we are doing right now so that if you have got any queries, you would ask those questions on Saturday in terms of our interactive session. The instructions in terms of the content that we are going to look at today are basically the same, right? We are going to copy the given views. We are going to construct the surface development of the transition piece with a specified seam given. We need to show all necessary constructions and all fault lines as required. I hear and I forget, I see and I remember, I do and I understand. The thrust of practical subject is to make sure that you are able to do it on your own, be able to apply the skills that you acquire so that you will be able to stand on your own in the examination and approach the examination with confidence. So, like always, I urge you to be practical. Take your paper, take your drawing board, take your pencil, and start drawing. You must live to draw and draw as you live. Thank you. Enjoy the lesson. Right, this is where we are today. Right, we are given the combination between a hexagonal and rectangular transition piece. Right, the bottom part is the hexagon, the top part is a rectangle, okay? So the front view and the top view of a regular hexagonal to rectangular transition piece. Draw to scale 1:1 the following views of the transition piece, the given top view, which is this one, the given front view, which is that one, right? So we are going to draw this one, as well as the development of the transition piece. So I want us to make sure that we understand, we follow this in terms of the procedure that we are going to have in coming up with the transition piece. Make AB the seam. We have got A to B, okay? That is our seam. But like always, I'm going to change so that we have got the numbers at the top and the letters at the bottom, right? Just to be able to coordinate the two. Show all construction, that's what we intend to do, to make sure that you are able to see and understand all the techniques that we are going to use. Let me just reposition this. Just a moment, boys and girls. I just want to stop sharing for now. There you go, okay? Technology, sometimes it misbehaves, but right, okay. Now, we have got a hexagon of side 40, okay? Right, so the first thing that we want to do is to copy that hexagon, then define the position of the rectangle, which is there. Right, so I'm going to draw a faint line like this. Push this one to the left a little bit. Then like that, okay? Right. Now, and measure 40 as the radius. Right, 40 as the radius. And draw a faint circle. There you go. Right, then stand at the bottom. You can either use a canvas, mark this side, and mark that side. Stand on the other end. Here we go. Faintly. I would need this one later on, so let me take these ones up. Right, so that is the hexagon. Right, I'm going to outline this. There you go. Right, and we are also given that the rectangle is 20 and 20, right? And from here to there is 20, which means from here to there, that's 40, okay? So I'm going to measure 20 this side and 20 this side, then 10 and 10. Let me just take this one up. Right, the framework is there. I can outline. There you go. Take this one up. remove that. Create a ground line just for reference purposes. Right, label this one X and Y like that. Understand? I'm just copying the views. Right, there you go. That's the top view, which is here. Then I want to define now the front view. Right, at this point from here to there, that's 40. Right, let me just bring this one. From here to there, which is from this point, that's 40. So I'm going to measure 40. Then connect. Then the other one, right, is 63. Right, I'm going to measure 63. And connect. Right, so the two are connected together. Like that. So that is the framework in terms of our view. Right, I'm going to outline this. Right, so then there's the triangulation which is already formed when we are looking from the south or from the bottom. Right, we are going to connect this point to that point and this point to that point. Let me just do it with a different line. Then there you go, okay? Right, I'm going to label this one. This is point A, this is point B, C, D, E, and F, okay? Right, and this one, point 1, point 2, point 3, and point 4. So the top points are labeled as digits and the letters at the bottom. But what it would mean is that this one, it's A, B, this one is point 1 and 2, and this one, which is a line, a point here, right? We have got points F, which is in line with point C, right? Then we have got this one, it's E and D, right? So it's A, B, C, D, E, and F, okay? Right, then the top part, it's point number 3 and 4, right? In reality, it should have been 4 and 3 because we start to see point 4 before we see point 3. Now, that's what we have. And if you check with regards to the information that we have, right, the top view on its own, just copying the top view and defining the lines in terms of the triangles for triangulation, you will have 8 marks. Then the front view, as it is given, you have 3 marks. Then the development itself, you generate 19 marks, okay? Right, so the next thing that we want to find now, right? We need triangulation assigned from here to there. Like that. But I'm going to use a different color, but just to define and make this one clear, okay? So from here to there, we've got a triangle, we've got a triangle. This side, we've got triangle, triangle, so that's fine. Then from here to there, there we go. But we have got another triangle, triangle, the other triangles are given. Now, once you have done that, the next thing that you're required to do is to find the true lengths, okay? Right, yesterday and the day before yesterday, I used a different method of taking the sides or the sizes from the top view, then relate to the front view in terms of the height. Right, now if you check this one, 1A and 2A, they are basically equal. So I'm going to say that this is line A, right? Which is the same as this one because they are connected to the same height. So this is A as well. Right, then I have from A to 2, okay? I would say this is my line B, like that. Right, then from there to C, right? 2 to C, right? This one is a true length, but 2, which is 2 here, right? And C there, right? I don't have a true length because they are both inclined, so I'm going to say this is C, right? To C. This one is the same as that one, so I'm going to say also that one is C, okay? Right, then I have got this one, which I would call D, right? Because it's connected to this height, right? So it's the same as F4 as well as 3C. So this one is also D, okay? Right, then I have got this one, which is connected to this point, which is 3. So I've got D3, but I'm going to refer to this one as E, right? Which is the same as E4. So there is E like that. Last but not least, I have got this side, which is F, right? Which is D to 4, okay? Right, those are the lines that I would want to find in terms of the true lengths, right? Then if you check here, right, we have got 2 to 3 as well as 1 to 4, right? 2 to 3 is here, it's parallel to the ground line. Automatically the other line, which is 2 to 3, is a true length. So I'm going to label this one as TL, which is the same as 4, 1, and 4, okay? So whenever I require this distance, I'm not going to take from here, though I know it's a rectangle, I'm going to take the size from there, okay? That is critical in terms of determining the surface development of a transition piece, right? So we said this one is line C, right? And this one we said it is line, this one is D, right? So I just want you to be familiar with these procedures so that on your own you can also be able to define the distances. Right, okay. Now you stand at point 1 and open to point A. Right, that description is already there. Let me just check. Right, I want to revert like this. So I'm going to do this. Describe an arc like that. And take this one up. Use a pencil like this. Get a point there. Right, point 1 did not change. What has changed is point A in terms of position. So there, right, I will come here. Use, there you go. Okay, right, this is line A. Right, that is the true length A. Right, the other line that I require is this one 2 to A. Okay, right, I'm going to stand at point 2 again. And to describe an arc like that. Once we have done that, so let me extend. Take this one up. And connect to here. Different color. There you go. Okay. But this is true length B. Right. I will write next to it like that. Right. The other line that I require is 2 to C. Okay, which is the same as 1 to F. Okay. But I'm going to stand again at point 1 here, like this. Then I'm going to revert like that. So point C has changed position. Take this one up to there. But so from here, which is that point, point C is now here, but point 2 remains the same. So I'm going to connect. Put a line. Yes, show this one in dotted lines, so as not to confuse the lines. All right, this is my line C, like that, okay? But that is the true length. Let me label TLC, like that. Right, okay? Then the other line that I require is 3 to C. But remember, 2C or C2, right? The height is here. It's not the same as 3C, which height is there, okay? Right, so I'm going to, let me take this one out, like this. Stand at point 3, right, and describe an arc. Take it up. There you go. So point C has moved from here to there, but point 3 remains there. And this is outside, so I can do this like that, which is line D. Sorry. Right, so stood at point 3, opened to point C, then reverted like that, take it up, pushed now point C to the new position, which is my line C. All right. Then from there, I need the true length for 3E, which is my E. Okay. So come here. Right, I'm going to revert like this. There you go. take this one up. Right, E has shifted to this position, but 3 is still there. Right, so I'm going to connect the new position to point number 3. Currently, right, this is my line E, okay? All right, last but not least, it's a D to 4, okay? But let me do it on the outside just to make it cleaner. Right, I'm going to stand at point number 4, open to D, right, and swing like this. There you go. Right, so D has moved from there, so we've eliminated one inclined line so that we remain with 1. Right, then take this one up like that. So D swung like that, then taken up, we have got a new true length. There you go, okay? Right, and this one is F. Right, and now we have got all the true lengths that are required in terms of the development that we are supposed to make or construct. Remember, if you are given a starting position, which is 1A, that's our seam. From this side, you would find that you are given the seam line, right? Like I've always said, the starting position is not an issue, but I can start here, mark a point like this. That is point 1, okay? Right, so that's my point 1 here. Right, then from there, I need 1 to A. Right, 1 to A is represented by the true length line A. So I take this true length here, take this true length, which is A, okay? Stand there at point number 1 and describe an arc like that. You have got now point A. So I'm going to label this one A. Once we have done that, this is our first line in terms of the development. Then you can outline this. Right, if you're not sure, you wait up until you are done with everything. Then you can define the line, okay? Right, now I've got point 1, I've got point 1, I've got point A. My next point is point 2. Right, so is this a true length? Yes, because on the other view is seen as a point. So which would make this one a true length. So take 1 to 2, like this, stand at point 1 and describe an arc like that. Right, then take the true length B, which is this B from here to there, right? Take this true length like that. You stand at point A, describe an arc like that. What you establish now is point number 2. So you write nicely, this is point number 2. You connect faintly, then you do the same like that. There you go, okay? This is not an outline, it's just a construction line, but slightly thicker than a construction line. Then outline this. Right, so this part, which is 1A and 2, the true size of that part is this one. So the next thing that we want to establish is point number B, okay? Point B, in terms of the link, we need to have point 2 to B as well as A to B. So B is common. So I'm going to take the true length to B, which is A. I already have got A. So I'm not going to waste the time on that. Take this one, right? Stand at point number 2 and describe an arc. Then you take AB. AB is a true length because here it is seen as a point. So I'm going to take this one like that and cut this one. There you go. Now we have got point B. Connect this one to there. Connect this one to there. And this can be outlined. Let me use a red pen. Now, there is a definite 10 there, but so what you require is to make sure that you are able to define that one as a fault line. Okay, I'm going to do that. That's the fault line. So now we have got the true panel of this one in its true size, right? That's what we have, okay? Right, then the next one that we want to find, we have got point 2, we have got point B, we need to get point C. Then from C, we get point 3, okay? Right, because we need this line first in order to connect with the bottom one. So point 2, which is this one, right, which should be connected to point C, right, B to C, right, B to C, right, this one is a true length, so I'm going to stand here, open to this point, like that, then describe an arc, like this. The next thing is 2 to C, okay, but the true length to C is this one, okay. So you take the true length, which is that, you stand at point 2, describe an arc. What we have established now is point number C, okay? At point C, there you go. At point C is connected to point 2, like that. Now, this one can be outlined because it's not going to change. So we have got the true size of this panel, 2BC. 2BC is represented here. So I'm going to outline this. Okay. Right. Now, once you have got this point, right, which means we can get point 3, right, from 2 to 3. But remember what we said from the beginning, right? Point line 2, 3 can only be taken from here because that's where the true length is. So I'm going to take 2 to 3 from this, like that. 2 to 3, stand at point 2, describe an arc like this. Right, okay. But you describe an arc, then you need C to 3, right, which is line D, okay? Right, C to 3, which is line D, which is on the extreme end, which is this one. Let's push this one slightly. But you take this one, which is line D, take this one, but you stand at point C, right? This will take you to like that, okay? So the point that we have right now is point number 3, so you can label there. this is 3, right? 3 is connected to 2, like that. And this one is connected to C. There you go, okay? Now, this can be outlined, right? This one can be outlined, it's not going to change. Right. Now, I have got point 3. The next one that I require is D. So you need 3D as well as 3E, okay? Right, 3D is the normal side of the hexagon. So take this one, stand here, and describe an arc like that. Right, I need 3E. Right, this is 3D, this is E. Right, I'll take the 3 to D from here, which is represented by E. Mark that. Right. There is point number 3, describe an arc. Right. The point that I gave now is point D, okay? Right, and point D is connected to C. And C is connected to there you go. Right. So we have this, right, and we have that as well. Right, this could be fault lines as well. That is from here to there, and this one as well. Right, let's do the fault lines later. Then connect. Right, the next one that I require now is point 4, okay? Right, point 4, which is from here to there. That's a true line, but I've got this one. Right, so I need 3 to 4. 3 to 4, I can take it from here, it's fine. Stand there and describe an arc. Right, then I need D to 4, which is F. D to 4, which is line F. Take it from here. Right, stand it in and describe an arc. Right, this is number 4. Right, that's point 4. Right, I can connect this one to there. Right, faintly like that. Then connect this one to there. There you go. Okay. Right. If you check this one, that one, and this one, and this one, these are the definite. So I'm going to show these ones differently in terms of the fault lines, then the rest would remain the way they are. Okay. Right. Now I have got point 4. Right. The next one that I require is point E. Right. Point E is as a result of D, E as well as 4E. I'm going to take this one for DE, stand here, describe an arc like that. Then I need line E, which is this one. I'm going to take that. Even from here, it's fine. Get that one, stand there and describe an arc. There you go. Now that's point E, okay? that. This can also be outlined. This is a definite fault line. So I'm going to show it like this. But the same applies with 3 to D. Then connect to this one. There you go. Okay. Right. So we are now here, right? Now the next one that we want to find is point F. Okay. Right. Point F, which is a combination of 4 to F as well as E to F. Right. If we take this. That is for EF. I'm going to stand at point E, describe an arc like that. To describe an arc, then I need line D. Okay, line D is the one which is on the outside. So take this one. There you go. Right, so that's 4 to F, which is line D. So you stand here, describe an arc like that. That's point F. This is connected like this. And there you go. Right, this can be outlined. It's on the outside. We refer to these ones as cut lines. Okay. Right. Now that we have got point F, we can definitely get point number 1. But we can definitely get point number 1. Okay, so that we have got 4 to 1, right? 4, 1. But here is the same situation like 2, 2, 3. So we're not going to take this one since the true length is that side. So I'm going to take this from here to there. Like that. You stand at point 4 and describe an arc like that. Right. Then I need C to 1 or F to 1, which is line C. But let me look for the true length line C, which is here. Take that like this. Stand at point F and describe an arc like that. You get point 1. Let us verify. There you go. That's it. You have that. Okay. I'm going to connect to this. Faintly, like that. Label this point 1. And point 1 is connected to point F. Okay. Then once you have done that, you now require to have point A, right? Point A is a combination of F to A and 1 to A. Right. So this one would take from here, stand there, and describe an arc. Just lower this. Right, okay. Right. So you are standing at point F and opened and describe an arc, the arc which is equal to the side of the hexagon. Right. Now you need 1A. Remember, we opened through 1A. So I'm not going to go up there, right? I'm just going to take this one like this, stand at point 1 and describe an arc like that. Right, you now have got point A. But point A is connected to point 1, it's also connected to point F. So, like this. There you go. Right. The next thing that we want to do is just to outline the cut lines from here to there. And you also do the same this side, you outline from here to there. Right. You also do the same. Right. Like that. Right. So if you are looking at the development of this transition piece, right? You need, first of all, just like I said, you need to copy the given views. Make sure that you copy according to the sizes that are given, right? And also project in terms of the front view. Once you have done that, you now create a series of triangles. Fortunately, with this task, the triangles for other surfaces were already given. So the one that we needed to define is this one and that one, okay? Now, from there, you require now to develop the true lengths, okay? Right, if you use this method of finding the true length where you need to rabat, right, like that, then take to the front view, there is no need for you to label true length diagram, okay? Because we are able to see where this is coming from. But if you do this, the true length separate from the views, right, you need to identify by way of a label to say these are the true lengths that I've used for my development, right? And make sure it doesn't matter whether when you are starting, whether this is horizontal or it is vertical, it doesn't matter. But what is critical is to make sure that you start at the given starting position in terms of the seam. Right, like here, that's 1A, I've changed, that was B, this was A, right? Just for easiness in terms of coordinating the points, I number these ones and label these ones A, B, C, D, right? And the end result is a development like this, right? Here, I've got a cut line, which is this one and that one, right? There, I decided to make this one a fourth line, which is this one, right? Also here at E, 3 to D, which is 3 to D, as well as 4 to E, which is 4 to E. I also decided to make those ones 4 lines. The rest should define that concept of triangulation that we are doing. Remember, the concept of triangulation basically is about describing the development in form of triangles, having established the true lengths. So you would label here, you would label development transition piece. Right, okay. So this is the development of a transition piece. So boys and girls, right, we have touched different elements of transition pieces, right? We started with a square to square, right? We looked at the one whereby the base is cut, right? We also looked at the square to a circle, right? Now we have looked at a hexagon to a rectangle, okay? So once you have got that understanding in terms of transition pieces, right, you can attack any question given with regards to transition pieces. Like I said, we are going to meet again on this topic on Saturday, and we recap on what we have done so far, then we consolidate the concept itself then. I hope you enjoyed the lessons on transition pieces, and I'm sure you have understood how we go about in terms of coming up with the development in transition pieces. Thank you and good night.